Hello, Mr. Tan discussing natural logarithm. So this is a concept that is not included in my lecture notes. So now I'm going to present to you what it means by natural logarithm. Okay, natural logarithm is written as ln x. Right? It's written as ln x. So the definition of natural logarithm is defined to be ln x. Ln x, which is a logarithm with base e. The e here is referred to a special type of number. Alright, a special type of number. We said that this number is an Euler number. Alright, e is an Euler numbers. Euler number. It's a special number by Euler. So this Euler number is a constant. It's a constant. So what's the value here? Okay, you will learn this more detail in your calculus in your university. So for now, I'm just telling you the value. You can get the value here by pressing this shift, the ln. There is an exponent here. You just key in power 1 here. So the value is 2.718281828. Alright, it cannot be changed into a rational number. Alright, it cannot be a rational number. One more information is Euler number is irrational number. Is an irrational number because why? It cannot be changed into a fraction. The Euler number cannot be changed into a fraction. It's an irrational number. So this type of number is very special. Okay, it's proven. It's applied in many applications, especially physics. Okay, physics, chemistry, biology also. They were using exponent and ln, the natural logarithm, in helping in study some model of some population or maybe some mechanism. Okay, right, radioactive decay. So ln x is log x to the base e here. So you should understand ln is a log. Alright, if ln is a log, ln apply all the law of logarithm. Okay, because it's a logarithm, just a special name for it is natural logarithm. So apply. So for example, if I have ln, right? If I have ln e, okay, ln e. So most of you were asking me, oh, what is ln e? Ln e is log e to the base e, right? Log e to the base e, because you know ln is log to the base e. So when you log e based on the law of logarithm, right? If they say log a and a, you are getting the value of 1. It's not, right? You are getting the value of 1. So, or if you have ln 1, students were asking, sir, what is ln 1, right? Without using calculator, for your knowledge, ln is a log. It's a log with the base of Euler number. So, and 1. So, any log value of 1 to any base. So, you are getting a value of 0. So, you should understand ln e is 1. Ln 1 is 0. Just like you have log to the base 10. Log to the base 10 of x. We can rewrite log 10 to the base, log x to the base 10 by using the short form of lg, log, right? Log x. This is the same, right? Just for log e, log to the base e, we're using ln x. So we read this as ln, ln x, alright? This one is log x, right? Log to the base 10. We can rewrite this, or we just leave it blank. All this is the same meaning. Log without anything written here is the log base 10, okay? Or lgx. So for this, ln x is log to the base e, alright? So you see, I try to do some comparison for you. So let's say if you have log, if you have log 10, right? Lg10. So you understood that log 10 is the same as log 10. So which is 1, right? Which is 1. So please jot down in the lecture notes that you have. So I will go detail about this. So log x, so means that in log 10 base 10, so you have 1. So same thing also if you have lg1, so you are still getting 0, right? You're getting 0. So same thing as this, alright? So just they're using the ln here, alright? Ln 1 is 1. So another form Another formula that you should know is, let's say you have exponential to the ln to the power of x. Exponential to the power of ln x. So you can rewrite this in the form of x. E ln x you can rewrite as x. Alright? So this is maybe it's considered new thing for you. So you have to take note about this. This one. So it's very important for you. So because it's going to help you in solving some form of equation. Alright? Some form of equation. So, alright. So based on, since you know that this is a natural logarithm, right? You know this is a natural logarithm. So definitely, you should know that it will apply all the law of logarithm. For example, you have ln, the product rule for the logarithm, right? The product rule involving law of logarithm. So for example, this one ln x multiply y. So because of multiply, you can write as ln x plus with ln y. Please take note about this. The first. So if you have quotient rule for the law of logarithm, you get the property. So you have ln x divided by y. You can rewrite this to the form of ln x minus with ln y. Okay, so it's the same, just like a logarithm. So let's say you have log x to the power of y. You actually can bring forward the y, so become y ln x. Y ln x. So this is the main thing that you should know. Alright, that you should know. Because okay, why can we apply this? Right? Why can we apply this? We follow this rule here. This rule here. So let's say if we have log to the base x, log to the base a xy. So we can rewrite this one to be log to the base a x plus with log y to the base a, right? So this is deduced from this law, right? This follow this law, because ln itself, ln xy itself is represented with log xy to the base e, right? To the base e. So that's why we can apply the law of logarithm. So for this, you know that you can apply the law of quotient rule for logarithm, and this is something that you should know, right? So what is so useful about this ln, right? Why we should learn this? So let's see some application of this before you learning chapter 2. So for example, if I have a number, if I have 2 to the power of 3x to the 3 to the power of x minus 1, for example, this one we have two alternatives. Alright, some of you may putting log base 10 both sides. So because of you have already learned the concept of ln, right? We can putting ln both sides. We can putting ln both sides. It's another alternative for you. So you put ln 3 power of x minus 1. You can put ln both sides. Ln both sides is the same as you put log both sides. Alright, log both sides. So, and because of this is a logarithm, you can bring down the 3x. Then you have ln 2. And this one you can bring down the x minus 1. Ln 3. Right? Ln 3. So, you can rewrite this to be 3 ln 2. This is a constant. And this is an unknown. So, I put a bracket here. So, then equals to, I multiply inside and have ln 3 x minus with ln 3, right? Definitely I will group the 3 ln 2 minus with ln 3x, right? So if you minus both sides by ln 3x, right? So you can factor out the x. Okay, factor out the x, then you have negative ln 3 on the right hand side. So then overall you can find the value of x, the solution for this equation, by negative ln 3 divided by 3 ln 2 minus with ln 3. You can using natural logarithm in helping you solving this type of equation, which cannot be converted into the same base. Alright, this index cannot be converted into the same base here. So how to using calculator in evaluate this? So very simple, you just key in. So you negative ln 3, this one, ln ln 3. Then you have 3 ln 2. Sorry, 3 ln 2 minus with ln 3. Then you are getting the value, which is negative 1.12 in three significant figure, right? So this is the solution for this. So definitely students were asking me, sir, can I apply log base 10? Yes, definitely you can. Definitely you can. You can apply log to the base 10 as well, right? You can apply this also. But I have tell you, this is an alternative, all right? An alternative for you. You can apply ln also. Ln is also a log, right? It's also a logarithm. Just is to the base of the Euler number, all right? Euler number. So I think that's all for this video. Hope you can understand. All right. Okay. Sorry. Before that, I have to share with you one more thing here, so that I hope the video not so long and make you very boring. So, okay, there is another rule just now that I should give you more example. For example, if I have exponential to the ln to the power exponential to the power of ln x here, the Euler number to the power of ln x here. So it should be x, you're getting the value of x here. So what happens if you have 2 ln x? If you have 2 ln x, so you have to make sure that you have simplified this by bringing up the 2 with the x, so x squared, before you rewrite this in the form of x squared. So the more general formula for this will be, if you have a function, if you are ln to a function of fx, so you can rewrite this in the form of fx, right? In the form of fx. So I'll give you some example. For example, you have e ln, right? E ln 1/2 x minus 1, right? You shouldn't write here as x minus 1, because there is a 1 or 2 here, right? So we have to apply this formula, this law. So where you have to make sure the coefficient is 1, so you have to bring the 1/2 to the power by apply the law of logarithm. Then you have 1/2 here, right? So then later on you apply the rule, exponent and ln, the function, then you just write out the function. So the function will be square root of x minus 1. Alright, I think there's a little sharing from me. Hope you understand what is the usage of the natural logarithm in solving an equation. Alright, that's all for this video.